Well, hello again, advanced algebra students. It's time to do our next section, which is going to be the inverse trig functions. So my camera appears to be a little bit blurry there. Let's see if I can get it to clear up here for a moment. There it goes. Okay, so we're talking about the inverse trig functions. And so first we need to understand again what an inverse function is. So if we remember here, before we look specifically at this, an inverse function is a function that takes something that came out of a function and sends it back to where it started. So if you remember my function box illustration where you have a box, you put something in, then the function brings out something else. Well, an inverse function undoes that. So whatever comes out, it takes it and sends it back to what it started to. So like for instance, if I talk about numbers, if I put the number, say 2 into a function and out comes 4, well, if I put 4 into the inverse function, then out would come 2. It undoes the original function. And so inverse functions basically become important. So like trig, we know that in a regular trig function, our input is an angle. We put an angle into it, and then the output is a ratio, that side ratio. Like for instance, if I ask for the sine of say 30 degrees, then the output is the ratio that I get of the opposite side over the hypotenuse when the angle is 30 degrees. So the output is that ratio. Well, there come situations where I may know the output, I may know the sides, but I need to figure out what the angle is. So to do that, I need to do an inverse trig function. So what the inverse trig does, it's if I happen to know the ratio, it takes the ratio as an input, and then its output sends me back to an angle. So that's what an inverse trig function does. Now the truth is most of this is going to be done with your calculators, but there are some that you do have to be able to look at and know. So let's look at the inverse sine first. Okay, here's the notation that we use. This actually does not mean we are raising the sine to the -1 power. It stands for the inverse sine. And so be aware when you see that notation, it does not mean sine to the -1 power. It does not mean take the reciprocal of sine. Okay, the reciprocal of sine is cosecant. The inverse sine is something very different. It's basically asking what angle gives me this sine ratio. The inverse cosine is written like this. Okay, we write it with the -1 power, but we don't mean we're actually doing the -1 power. And the inverse tangent is written just the same, y equal to the inverse tangent there of x. So let's look at some examples. So we need to have our reference triangles in mind when we look at these. These are the ones that we have to be able to do without a calculator. So it says find an angle between 0 and 90 where the sine would be 0. So if I want the sine to be 0, that means that the opposite side would have to be 0. Okay, well the only time the opposite side is 0 is if there's no angle here, so that would have to be when the angle is 0 degrees or 0 radians if we want to think of it that way. There's a picture of it illustrated there on the unit plane. Now let's say I want the sine to be 1/2. Well, I need to recognize that 1/2 is a ratio that I get when I'm talking about 30, 60, 90. These involve ratios that have either 1 or radical 2. These involve like 1/2, radical 3 over 2, 1 over radical 3. So they involve those. So I recognize this and I look for the sine ratio. Well, the opposite needs to be 1. The hypotenuse needs to be 2. So the angle that would give me that 1 over 2 for a sine ratio would be a 30-degree angle. So my answer there would be theta equal to 30 degrees. How about if I want the sine of radical 2 over 2? Well, notice there's no radical 2's in this at all, so I know I have to go over to this one. And I want the sine to be radical 2 over 2. I need to recognize that's the same as 1 over radical 2. So in that case, the only angle that's a possibility is 45, so it's got to be 45 degrees. The truth is, once I know that this comes from this triangle, it's going to be 45 degrees. That's the only angle that I know. Now, if I want the cosine to be equal to 0, notice the cosine to be equal to 0. Now, the cosine is the adjacent side here. So to make this side go smaller, I have to keep moving this side shorter, 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 shorter. And what happens to that angle is it keeps getting bigger, 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 bigger like that. So the cosine of 0, if I want to think of it that way, is 90 degrees. I could also think of it in the unit plane here, that for the cosine to be 0, the x-coordinate has to be 0, so I would be right here at 90 degrees. That would make my x value of 0. I want the tangent here of theta to be 1. Well, the tangent is going to be 1 when the opposite over the adjacent is 1. The opposite over the adjacent are the same size, so it's not this. Here's where the opposite adjacent are the same, so once again, 45 degrees. So we're just moving through and we're just picking these out of those reference triangles. Now, a number of them will also be use your calculator. So these should be pretty straightforward. We just have to know where this is on our calculator. So we're asked for the inverse tangent of negative 3.6. So what we'll have to do is take out our calculators, and I'll show you on your calculator. Let me hit the light here so that doesn't reflect off that screen so badly. Okay, so with my calculator, I'm going to want the inverse tangent. So what I'm going to do is I'm going to go here, and notice it's all going to be under this trig button right there. It's all going to be with the same place that all my other trig functions are found. It's under the trig. So let's go and let's look at that. Let's push that button and see what pops up. So when I push that trig button, whoops, let me get to my calculate screen. When I push that trig button, this is my menu that pops up. And notice inverse tangent is found right here. So I can either use the arrows to get there, or I can simply keep hitting the trig button and it keeps advancing until I find I'm at inverse tangent, and I hit enter. And now I put in negative 3.6. Now here's where I have to know what mode I'm in, because remember, this is a ratio. What's going to come out is an angle. Notice right now my calculator is in radian mode. So when I hit enter, I'm going to get the radians. So it's going to be negative 1.2998 radians, or negative 1.30 radians. So if it wants radians, that's what I would give for an answer. And so in this case here, that would be my answer. But if it does want degrees, if I want to go back there and get it in degrees, I have to do one of two things. Either I have to tell it to give it to me in degrees without changing my mode, which means I have to hit my book, which my book, remember my catalog, is this button right here. So if I hit my catalog, I look for the choice that's arrow DD. If you need to jump, remember in your catalog, just enter the letter that you're interested in, and it'll jump right to that. So if you enter D, then you'll jump right to the D's, and it's pretty easy to find arrow DD. What that is saying is I want to change it to decimal degrees. So now when I hit enter, it gives it to me in degrees. The other thing that I could do is I could simply change my mode to degrees, and then I would get an answer in degrees. Now let's look at the inverse sine of negative 3.6. So now I go in here to my calculator, and I put in the inverse sine of negative 3.6, and I hit enter, and I get this error message. Why do you suppose I'm getting an error message? Well, the reason is because notice what I put in for a ratio was negative 3.6. Think about the sine function. Is the sine function, do we ever get negative 3.6 out of the sine function? The answer to that is no, it never goes lower than negative 1 or never higher than 1. So the error message here is because there is no angle. that makes the sine function equal negative 3.6. There's no angle that does that. So the answer there would either be undefined, or you could say there's no angle. There is no answer to that. Okay. All right, let's go ahead. Let's take a look at the inverse cosine of 0.739. So going back to the calculator. So I'll hit OK there, and no, there's nothing to that. But I will go back here and I'll go inverse cosine. And my thing is 0.739, so that's 0.739. Enter it. And I get my answer there of 0.739. Interestingly enough, in that case, the angle is actually the same as the ratio. Rather unique situation going on right there. Okay. There's your homework, 8 through 18 all. There will be some where you have to look at the reference triangles, and then there will be some where you just simply punch it in your calculator and record your answer. Do pay attention to whether it's asking for answers in radians or degrees. Okay, hope things go well, and we'll see you with tomorrow's video.